So my math lab calls it a QQ plot, but I call it a normal probability plot. So if you have a small set of data, then you're going to actually put them in your calculator and graph it. And we're going to decide based on this plot whether we have a normal distribution or not. So plots A and B show two different sets of data. This is a normal probability plot. And what we're looking for, basically it takes all of your data and it calculates z-scores for all of them and then puts them on a scatter plot for you. And so what we want is for our z-scores to be evenly distributed. We want them to create a linear pattern so that we have some that are negative and then some that are positive. So you see that vertical line at 0. What does it mean to have a negative z-score? What does that tell me about my data? Like if you have a negative z-score on your SAT, what does that mean? You're below average. You scored below what the average score was. If you have a positive z-score, that means that you're above average. So in a set of data, we want some people that are below average and we want some people that are above average. We want that to be evenly distributed. So if we look at figure A, my data is approximately normal because I have a linear pattern. So I would say since normal probability plot, and you can shorthand it like this, NPP is approximately linear. The data is approximately normal. So using the word approximately is going to kind of save me. I'm not saying that it's exactly linear and exactly normal, but it's approximately. So we can just kind of have that gray area. But for B, clearly that data is curved. So we would say since the normal probability plot is curved, or you could say not linear, data is not normal. So we're looking for something like this, but plot B is not okay. That means that we don't have a normal set of data. It's going to have a skew or a curve or something like that. So we could not go any further. If for some reason on a test or something like that, or a quiz, you end up graphing the data and it's not normal, and I still will ask you parts B through D, like tell me the probability of this, tell me the probability of this. I still want you to answer those questions, but out to the side, if it doesn't meet all of the conditions, you would just say proceed with caution. So it's like, I'm going to answer these questions and they may or may not be right, but my conditions aren't met, but I'm still going to keep going. So if this were like an AP class or something, you would still keep going and answering the questions, but just say proceed with caution. That was my favorite phrase whenever I took AP stats, because we would just say everything proceed with caution. Just kind of a funny phrase. It doesn't happen very often where your conditions aren't met, but if they aren't, then you just keep going anyway. So example 2, the data in the table below represent time spent waiting in line for the Demon roller coaster. For 100 randomly selected riders, is the random variable wait time normally distributed? So this is a histogram. Wait, I don't know why it switched. I think I clicked it. Go back. Zoom makes my computer so slow. I feel like I complained about this before. I don't even know where my mouse is. Okay. So the first graph is a histogram. The second graph is a normal probability plot. And so I'm going to look at the normal probability plot, and based off that, what could I say about my distribution? So since the normal probability plot is what? Curved. So it is not linear. So it is curved. What is my context? What am I measuring here? Wait time. So the wait time is not normal.
Where's the eyeballing is?
Yeah. I mean, that's clearly curved. It'll be pretty obvious whether it's curved or linear.
So that's for the right? That's the right graph?
Yeah, because this is a normal probability plot. And I can tell by, you see how it's going to look like a scatter plot. And it's going to say something about norm. It's going to have the word normal somewhere.
So why is the histogram normal?
Well, it also, I mean, you can't make any inferences based off the histogram.
Okay.
But it's there to show you, like, okay, this is clearly a curved distribution, and the normal probability plot proves that it is, in fact, not normal. But based off the histogram, you can kind of already tell it's not going to be normal, because a normal graph would look something like a bell curve. Okay, so let's look at the next four. We have top left, top right, bottom left, bottom right. And out of all of these, this is kind of where it gets a little hairy, I guess, because I think for the most part, especially on your test, it's going to be pretty obvious, but there's a lot of debate and discussion amongst these whenever it may not be exact. So looking at the top left, what do you think? Would I say it's normal or not normal? Yeah, I would say not because of this little guy over here. So I would say not normal. What about the top right?
No, because the bottom.
Yeah, it's not normal.
It's kind of generally curvy.
It's generally curvy. I like that. What about bottom left?
Yeah.
I say yeah. And like I said, these are pretty, I would say, up to your discretion. But for the most part, it's going to be obvious. What would you guys say about the bottom right?
Yeah.
I would say yeah, normal. If you completely disagree with me, we can maybe make an argument towards one or the other. But that's just what I would say. So just go with your gut on these. All right, so those are if the plots are already graphed for you. I think on my math lab, most of them are going to give you the graph themselves. But for instance, if you don't have a graph, we're going to actually learn how to create one. So go ahead and get your calculators out. And I want you guys, so this is 24 individuals, which means that we don't have 30, so we can't say that it's normal because we don't have 30 of them. So it says determine if the conditions are met for a normal distribution, then calculate the mean and the standard deviation. So what I want to do, first condition is, what's the first condition always?
It says random.
Random. So randomly selected 24 individuals. Second one is deciding is the normal condition. So I'm going to take my data, my 24, I'm going to put them all in list 1. So go ahead and type those 24 data points into list 1.
Well, the second condition was just, is it greater than
So
30?
it'll just do 1, 2, 3, 4.
Well, it is, but it's not greater than 30. So we're learning in this section, well, what if it's not greater than 30? How can we check if it's normal or not? So we're actually going to create a graph. So for now, we're just typing in the data points. Yeah, type them all into L1. I know it's in 2 rows, but they all need to go in list 1. So did you guys watch the videos during class, or did she teach, or what?
She taught us.
Okay.
Did you cross out the conditions?
I underlined it, or I tried to. I've had a lot of coffee this morning.
Is Miss Fuzika ever gonna come back to like visit us? Or is she just gone forever?
She's gone forever.
What?
No, she'll probably sub.
She's trying to get.
Oh yeah, she's trying to get Mr. Cunningham job.
Yeah, she's trying to get his job? I didn't think she wanted to come back full time. I thought she was trying to come back full time.
I would say that'd be pledged, but we're gonna be going next year, so. Well, I mean.
Yeah, we liked it.
We hope you're gone.
She was good.
Yeah, she's so
Provided we pass
nice.
this,
She got me a gift. She got me a little book and a book for Mia and a book for Pearson. It was really nice of her.
I need to
Same boat.
graduate. and walk
Yeah.
across that
We're
street.
about on the same reading level, so
You never know.
Oh no!
anytime I try to read a Pearson, he just starts crying uncontrollably. So I don't think he likes to read.
I don't think.
What about when Patrick reads to him?
It's okay.
He-
What if
he doesn't read
wants
to him.
We gotta let go.
Yeah, but he loves math. That's all I really care about. So
How do you know he
He
loves
doesn't
math?
scream.
I can just tell.
He doesn't scream when he's.
Yeah.
He doesn't cry.
I'll show him
uncontrollably.
multiplication facts. He doesn't cry. So in my book, that means he likes it. Okay, does everyone have their data typed in? Okay, so from here, we're gonna create a graph. So I'm gonna go to second y equals. If you are an Inspire person, I hope you know how to make a graph by now. Micah, why don't you have a calculator?
He doesn't.
Oh, okay. Oh, you were hiding it from me. Looked like you were texting or something.
My phone's right there.
So I'm going to, I'm gonna hit plot 1 and turn that on. For type, it's gonna be the very last one. So either bottom right or
Oh, it looks like
just the last one. So it's very interesting. I'll kind of just go through all of the graphs. So the first one with the dots, that's a scatter plot. Then the next one, it's a scatter plot but connecting the dots together. The third one is a histogram. The fourth one is a box plot. So we only really use 2 in this class. We use the box plot with the outlier. The fifth one is a box plot, but it doesn't show outliers, which why would you ever graph that? I don't know. And then the last one is a normal probability plot. So in this class, really, the only 2 that you're ever going to use is this one, which is a box plot, and then this one, which is a normal probability plot. So if I ever ask you to graph something, you're either going to use box plot, normal probability plot. Those are pretty much the only 2. So click that one. What it's doing is it's taking all of your data points and it's individually calculating z-scores for all of them. So that z-score formula that we gave you, it's the calculator is doing that for you in like 1 second. Then I'm going to graph it. So hit zoom 9.
Wait, did we change anything else?
No, everything else should be normal. Zoom 9.
Wow.
Where are some of them filled in and others aren't? Or is that just...
I think that just means they're overlapping.
Mine doesn't show like the X and the Y.
I don't. I think that's like a setting.
Do we have to do this by
You might need to clear the memory. So, do you know how to clear the memory?
Like second plus 7.
Yeah. Try that, and maybe
Do I
that'll.
need them like that?
I don't think so. Well, you would want the x-axis because that shows that this is 0. So,
Oh, okay.
Okay, go into y equals, and you might have some sort of random graph in like a y1 or something. Okay, so on your paper, I'm not going to exit out of this because then it'll go away. So for your second condition, I want you to draw this graph. You don't need any numbers, but I want you to draw the x and y axis. So vertical, your y-axis, your x-axis, and what you'll label it as is the y-axis is your z-scores, and then your x-axis is going to be whatever data, like whatever the context of the problem is. So in this case, what are we measuring? Like what's the context? What do these numbers represent?
hours versus
hours spent studying. So my x-axis will be hours spent studying.
How would you actually going for me?
And yeah, I don't really care that much. I mean, there's no numbers. I just want you to kind of fill in the dots as best you can to get a general sense of the shape. Josh, Luke, did y'all get it figured out? No? Okay, let me come look at it. X-axis is going to be your hours spent studying.
Okay. That looks good enough.
Yeah, that looks kind of liney to me.
Look at mine. I didn't even try.
It was a little 33.
Just the
Right.
curve. I'm ready to go home. I can't do this.
What?
There's no way.
There's not?
No, no.
There's not.
I've done worse. My stick and
It's just
poke hurt
water.
more than actually, yeah. Like the
It's
one
just
that's on my
water.
finger.
How long is that one stay?
What?
It's supposed to stay for a little bit and
Hey,
then
Brett, what you talking
it
about?
fades, but I know some people who are like, they got it in their teens and now they're like in their late 20s and they still have it.
Yes.
Does Avery Rudd still have hers?
I think so.
Sorry, what?
Yeah.
Yeah, she got one like right after she graduated.
Yeah, as soon as she graduated.
What
she
did it
got
say?
I don't remember. It was something stupid.
It was something sinful.
Yeah. Yeah, I know.
I'm getting one of my
I just should, period. I was gonna get them done earlier, but I just like haven't had time because I work and stuff.
I'm just gonna get a huge sleeve down on my birthday. Just
Nice.
shoulder all the way down to the wrist. They'll never know because I'm wearing my sleeve.
Well, like my first real tattoo's gonna be soon. I meant to get it on my birthday, but I just paid the lady to do the commission on my tattoo.
There we go. Okay, so you either
Hopefully
add
I'll
it to
have
the
it
X
by
or the Y
next month.
axis.
Oh my god, that means I have to drive an hour tomorrow to get my thing touched up. I hate it here. Anyways.
Yeah.
Forgot I got it in
add data,
Oklahoma.
split it, and then click to add variable.
Jog in a Wednesday.
Yeah, I won
and
150
then
bucks.
new menu.
What'd
Get
you
it.
play?
Blackjack.
Yeah.
Yeah.
Yep.
I'm a god at blackjack. Let me just tell y'all.
Okay.
It took me so long to buy in though because so many people were like waiting there, and they were all old, middle-aged men who smelled like cigarettes.
Okay, so from here,
Honey mustard?
I would say, what would be my comment on this? Would I say that this is linear?
No.
That's pretty liney
That's
to me.
that's linear
That's
to
linear
me.
to me. That looks very
How is that curvy?
That's liney.
Don't try to make it more than it is. Just go with your gut.
Yes.
What does your gut tell you?
Yes.
My gut tells me that's very liney.
Yes.
Yes.
My gut does not.
Yes,
It's not
curvy.
curved. That's not
Liney.
curved.
Yes.
No.
According to
Yes, Lily.
Lily.
Look how Lily's feeling.
God, like she has a big
Lily,
headache.
Lily woke up with a cold, actually.
Okay, so you need to clear your memory. So you hit second plus 7, 1, 2. If you guys ever have issues with your calculator, just clear the memory. It's gonna
How do you
fix
do-
everything.
how do you do
Second
that?
plus 7, 1, 2.
That's too many numbers to
Yeah.
remember. I think I'll just
You're
email
welcome.
you if I-
My algebra 2 teacher made me clear it before every test, so it's just like in my memory. It's never gonna go away. So on this graph, I would say since the normal probability plot is approximately, see, I'm using the word approximately so I can get away with it. Approximately linear. The,
Is this another like criteria or whatever?
yeah,
Okay, so number 2.
the hours,
Number 3.
no, this is 2. So this is in place of what you've already learned.
graph was number 2.
Oh, this is a part of number 2. This is all
Oh,
All number
I was
2.
about to say, man, what? I am so.
This is all number 2, the graph and the sentence
Okay,
that goes with
okay.
it. The hours spent studying is approximately normal. That is one sentence. That's not a lot of words.
But every time.
This isn't too bad. You just have to draw a little bit and write a little bit.
Yeah.
It's better than last student.
True.
What was last unit? Probability?
Yes.
Well, no, I hated the
Oh,
one.
yeah.
I hated the one where it made us write out all of the pairings.
Just to find out
and
what
then
we already
calculate
knew.
the average of all the pairings, just to
We're
prove that
still gonna-
calculating the averages of all
We're
those.
still gonna
Equals
have to
the
do
number
that.
they already gave
The
us.
Yeah.
test is Monday.
Yeah, I don't really like that
Oh
section.
yeah, why do we have to? Is there ever a time it won't
Anyways.
like do that?
No.
Then what's the point?
to show you that it works.
But how many times? Like in Mr. Cunningham's class when he was showing us like this is why it works, it was, what did he call them?
Proofs.
Yeah, no.
Ew, I hated
It
fruit.
wasn't proofs, it was something else.
Okay, so we have now shown that it is normal. So we have the criteria, the conditions are met. So then it wants us to calculate the standard deviation, or the mean and the standard deviation. So the mean is equal to what? How could I figure that out?
One variable.
One variable statistics.
Is this
So
number 3?
no, this is, now I'm doing this. So I only have two conditions. I did the normal, or I did the random condition, and then I did the graph and the sentence. You guys should have that on your paper.
How many decimals?
So to find the mean,
We should have what on our paper?
the,
Yes, the
Wait, but there's
randomly
nothing in
selected,
L2,
the-
Okay.
Yeah.
So
Yes,
it's
Nick?
just like, I'm so confused.
Yeah.
And then the other
Yeah,
ones
that's it.
are- Okay.
How many decimals do you want us to run through?
how'd you get a number?
second plus 7, 1, 2. That's how you clear the memory.
So,
I'm lost.
Lost
That's
on
just how you
what?
clear the memory if your calculator's
Oh.
messing up.
Yeah, that's how you clear memory.
I thought you were talking, that's
No.
how you find the mean of it. I was like,
I know. Okay, so to find the mean, I'm going to go to stat, calc,
there's nothing in one that.
enter, 1 var stats.
There's nothing in L2, it doesn't give you a number.
You don't need L2.
So you just did.
You just do
Make them
L1.
both L1.
Yeah.
How do you do that again? You do second one.
2
So
plus
that would be
7. What's the
13
thing
point-
next to 7?
What's decimal point again?
I really couldn't tell you.
Go 2 decimal places.
What's the thing next to 7 on clearing the memory?
13.67.
Just begin.
Do what?
What's the thing next to 7 on clearing the memory?
1.
1.
Yeah.
Why?
2. 1. 2 plus 7.
Second.
We're losing our mind, people.
Second.
And it is only almost 10:45.
Oh yeah, look. It's pretty, once you do, if you do second and then plus.
Did you do, are you trying to graph it, or what are you trying to do? Find the mean?
Should we take a mental break?
Okay, so when you're graphing, you need to, here, let me show the graph really quickly.
Your calculator's being weird.
Yeah, that's a daily grid and I just like
Okay, where is it?
I did too. I forgot to do Nancy.
I got a baby.
I don't know where my-
Oh.
My mouse just like literally goes away. I don't know
I
where.
found out that if you start
There it
at
is.
11:55 and do 25
Okay,
minutes, apparently it counts.
So from here, so you have data typed in list 1, is that right?
But it's
Nick?
in there.
Okay, then you're gonna go to second y equals,
I'm like 90% sure. That's
and you choose the last graph that will go. Second y equals. So plot 1 should be turned on, and then the rest should be turned off. And then for type, you would choose the last one, and then data list should be list 1, data axis. Then you hit zoom 9. Also check to make sure that you don't have, since you cleared the memory, it should all be, there should be nothing in y equals, but you want to make sure, like I even have something in there, but clear that. There should be nothing in, yeah, perfect. That looks good. Oh, okay. Okay. So then if I want to calculate the mean, I'm going to go to stat, calc, enter, and I'm going to use 2 different numbers from this. My mean and then my standard deviation. So my mean, I'm going to write it as mu with a little subscript x bar. That's
Are we on
the,
the next one?
we're on the first one still.
Still explaining the first one.
Oh.
The mean is 10.92.
It's on line 50.
Oh wait, I didn't get. I got 13.67.
Oh, really?
I got 10.9.
I got 10.92.
Well, I got 13. I got 13.6.
Did you guys
Did y'all
just
type it in correctly?
Did you guys forget to put a number in? How many
Wait,
numbers
how
did
do you go to
24.
Yeah. 24.
Let me see.
How do you go to type in the things again? This is bad.
What did y'all get?
I got the same.
10.92? Okay.
Go to the bottom.
Okay.
That's good.
Yeah, so just make sure you type them in all correctly. And then I'm going to use my standard deviation.
Typed in 24 numbers.
We typed them in.
I typed them in right.
So
got
standard
10.92.
deviation would be, oh, I bet, you know what? Okay, go back to stat calc. Make sure that you have nothing in your frequency.
What is that? Stat.
You used frequency during the probability unit.
I thought you said make frequency L1, L1.
Yeah.
No, it's L1 and then blank.
Oh.
How do you make it?
Just hit clear.
Oh, that changes it. So we
There we
did
go.
do it right.
Okay.
I knew.
Yeah, so your frequency should have nothing in it. So standard deviation is going to be 5.48, but it's of this sampling distribution. So the formula, which you'll get this formula, but you divide it by the square root of my sample size, which is what?
We have the formula. 24.
24. So I'm going to calculate 5.48 divided by the square root of 24. I don't know what that is.
Can't off the top of your head that one?
You know, I could, but I don't want to show off too much. So
She's doing it for us.
I'm just making sure you can do it.
1.12.
1.12. So that's my mean and my standard deviation.
So how did we
Wait.
get 5? Oh, I'm dumb.
Why is that standard deviation instead of the standard deviation it gave us, Cameron?
Because it's of the sampling distribution, so the sample size matters.
Ah,
It's
Yeah.
different than the population.
How that is saved.
this, I understand that you have said those words.
Exactly.
Okay, now we've done all of that. I want you to try doing example 5 by yourself, start to finish.
Wait, so like last time, how we had to do the it is greater than 30 or the 5. So now we like just don't do that ever?
Well, the reason why we don't do it is because we don't have data, like we don't have more than 30. So usually what I tell my students is like, if they list out the data points for you, odds are you're probably going to have to make a graph. But if they don't give you the data, then it's probably going to meet one of those conditions like NP, N1 minus P, or it's greater than 30. How do I know like which one, how do I know whether to do, this is a side note, but how do I know whether to check NP greater than 5, N1 minus P greater than 5, or N is greater than 30?
The 1 greater than 5 is only for proportions, right?
Right. How do I know something is a proportion or a mean?
The mean one, it like gives you the mean and the standard deviation.
Right.
So this one would be.
Or it'll have the word mean and standard deviation in the problem.
Yeah, this one doesn't.
And then, like, you have to read the paragraph, but it'll say the word proportion or it'll say mean somewhere in the problem. Okay, so I want you to try example 5, make a graph, find the mean and standard deviation.
Is if it's less than 30.
Mm-hmm. Or the NP, N1 minus P doesn't meet. So we have our first condition, which is random selection of 10 days, randomly selected. Number 2, so my data is less than 30, and I don't have, so I can't say that it's greater than 30, it's normal, so I'm going to have to graph it. So I graphed the normal probability plot. It's approximately linear, so the data is normal. And then to calculate the mean and standard deviation, I do the 1 var stats, stat calc, enter. It gives me the mean. And then the standard deviation I have to divide by the square root of 10. Okay,